Alright guys, let's see how we can solve another question from the second chapter of the Meriam textbook, Engineering Mechanics. And in this question, for the angular position theta, which is 60 degrees of the crank OA, the gas pressure on the piston induces a compressive force of P in the connecting rod along its center line AB. So we have a force P in here, and we know that this force produces a moment of 720 Newton meter about the crank axis point O. So we have the moment of this force about 0.0720 Newton meter, and we are asked to find the force P in here. So before we start, let's just figure out some of these missing dimensions that we have. So we have this right triangle in here, and if we just call this point O and we connect this to here. So from the question, we can see we have some dimensions. This will be B, we can call this A, this will be O, and we can call this point here C. So we know this angle is 60 degrees. This is our theta from the question. We know it's 60 degrees. We have AB 300 millimeter. We have OA 125 millimeter. And this is going to be our force P, which we are trying to figure out. So basically, we know that the moment of that force P about point O is the value that we have in here. So if you want to find the moment of that force about point O, we basically, if we break down our P into two components, one horizontal and one vertical, we can call this one, we just call our X and Y in here like this. We know that Py won't make any moment because it's going to pass through the point O, so no moment from that component, but we have the moment of Px. So for finding the Px, we need this angle here, which we can call it maybe phi. So for finding the moment about point O, we're going to call counterclockwise positive as always. We're going to have the moment of Px, which will be P sine of phi, and the moment will be counterclockwise about point O. So we're going to have a counterclockwise moment, so that's why we will have, it will be positive because we assume counterclockwise positive. So this will be our force, and we also need the distance of O to B. So we need to figure out two things. First, the angle phi, and second, the OB. So for OB, we can find, if we look at this right triangle that I'm highlighting in yellow, in here, finding OC is pretty easy. So if you want to find OC, I don't know why I put a vector sign in OB. So if you want to find OC, we'll have 125 cosine of 60. So let's calculate this. 125 cosine of 60, that's going to be 62.5 millimeter. So we figured that this is 62.5. And also we can find AC pretty easy. AC would be 125 sine of 60 degrees. So 125 sine of 60, that's going to be 108.25 millimeter. So now that we have that, we can easily find our phi because we have the opposite of the phi, which is 108.25. And we also have the hypotenuse of the bigger triangle that we have. So if we do sine of phi, we're going to have 108.25 divided by 300. So now we can find phi pretty easy. Sine inverse of 108.25 over 300. Sine inverse of 108.25 divided by 300. Our phi would be 21.15 degrees. So now that we have our phi in here, we should be able to find OB pretty easy. OB would be BC minus OC. We already have OC. Figure out that OC is 62.5. And if we want to find BC, we basically have 300 cosine of phi, which was 21.50. So that's going to be our BC. And OC would be what we found the first step, 62.5. So now we should be able to find the OB. So 300 cosine of 21.15 minus 62.5. That's going to be 270.29 millimeter. And if we get back in here, we have phi, we have our OB, and we know this will be equal to 720 Newton meter. So we have to watch for the unit conversion because everything in here is based on millimeter. So 720 Newton meter is equal to P times sine of phi. So sine of phi would be sine of 21.15 times OB, which is 270.29 divided by 1,000 in order to get it in meter. And after this, we should be able to find our P, 720 times 1,000 divided by 270.29 sine of 21.50. So let's calculate this. 270.29 divided by sine of 21.50. So our force P would be 9,183.6 Newton, or if we want to report it as kilonewton, it will be 9.1. We're going to get 9.18 kilonewton, and this is going to be the final answer for this question. Hope everything was clear. Let me know if you guys have any questions, and you guys take care. I'll see you in the next video. Have a good one.